Assalamualaikum warahmatullahi wabarakatuh and good day class. So today we will continue our lesson still in chapter 4. So we have done 4.1, 4.2, 4.3. So today we want to look about 4.4 part 1. Okay, so today we will cover learning outcome A until D. So here is the learning outcomes for today's lesson. So at the end of the lesson, you should be able to explain covalent bond cleavage, homolytic cleavage, and heterolytic cleavage. B. Differentiate homolytic cleavage and heterolytic cleavage. C. State the relative stabilities of primary, secondary, and tertiary free radicals, carbocations, and carbanions. D. Compare the stabilities of carbocation and carbanions by using the inductive effect of alkyl group. So we want to talk about covalent bond cleavage. So all chemical reactions involve the breaking of bond and the formation of new bonds. So the breaking of chemical bond is called fission. There are two types of covalent bond fission or cleavage. First one is homolytic cleavage. The second one is heterolytic cleavage. So what is homolytic cleavage? Homolytic cleavage is the type of bond fission in which the two electrons of the covalent bond are split equally between the two atoms joined by the bond. For example, we have Rx. Both of the electrons that share between R and X here will give to each of the R and X. So each atom will get one electron, also known as homolysis. So each atom gets one electron. The resulting species are known as free radicals. So the product here known as free radicals. So what is free radicals? The free radicals are an atom or group of atoms which contain an unpaired valence electron. What does mean by unpaired? Unpaired means that one electron only. So, if you want to show the electron transfer, here is the example for homolytic cleavage. So, as we know, each bond, okay, for example, bond here, atom A and B. So, each bond here, we have two electrons, like this. Okay. So, one electron, we will transfer to A. So this one is half-headed arrow. Separuh arrow, half-headed arrow. Okay, that shows that just one electron transfer. So another one, the second arrow, also the half-headed arrow. Cuma kat sini tak berapa nampak. Okay, so it will give to B atom. So it become free radical. So here, the electron shows that after transferring the electron. Okay, so just a dot. Okay, that shows it is electron. Okay, so that's mean A and B cleavage and produce free radical. So free radicals are reaction intermediates. Alright, so reaction intermediates maksudnya di tengah-tengah. Okay, bila buat reaction, okay, the before get the product, okay, kita akan dapat the intermediate dahulu. Okay, so free radical is one of the reaction intermediate. Okay, so so free radical is very reactive and very unstable. Okay, sangat-sangat reaktif dan very unstable. So maksudnya dia takkan jadi produk, tapi dia hanya pertengahan before get the product. Alright. And then, what is heterolytic cleavage? Heterolytic cleavage is the type of bond fission, also bond fission, in which both of electrons of the covalent bond remain on one of the atoms. For example, here, both of the electron here give to the R. Okay, both of the electron here we give to the R. Why? Because R, let's say for example, let's say R is more electronegative, so R will get both of the electron here. Okay, so we will produce an ion and cation. So the headed arrow here is full headed arrow, right? Because of both of the electron transfer. Okay, also known as heterolysis, the heterolytic cleavage produce positive and negative ions, okay, an ion and cation. The two shared electrons split unequally between the two atoms. Alright, split unequally. Okay, so satu atoms akan dapat boost and then another one tak dapat apa-apa. Okay, that's why the positive here. And then the negative here because the R atom has more electron, kaya dengan electron. The breaking of the bond can occur in two ways. Okay, whether the A here get both of the electrons, so it become an ion. Okay, B become cation. Okay, because of the A is more electronegative. But if B is more electronegative, okay, B will produce an ion. So A will known as cation. What is reaction intermediate? A chemical species that is product of one step and the reactant for the next step is called an intermediate. So we have three types of reaction intermediates. Okay, kita dapat intermediate ni adalah daripada cleavage. So how many cleavage that we learned before? Homolytic and heterolytic. Homolytic will produce free radical, right? And heterolytic cleavage will produce cation and cation and an ion. Alright. So we have three types of reaction intermediate: carbocation, carbanion, and free radical. So what is carbocation? Carbo is come from carbon, and cation is positive charge. And carbanion is carbon with negative charge. Free radical is the atoms or group of atoms that have one electron. So the intermediates are unstable and highly reactive. So carbocation or carbonium ion is very reactive species with a positive charge on a carbon atom. Okay, yang Madam cakap tadi, it form in heterolytic cleavage. For example, we have this structure, this substance. So look at here, the bond between carbon and chlorine. Chlorine is more electronegative. It is partially negative, and carbon is partially positive. So the electrons here between the bond, so one bond we have two electrons, right? So both of the electron will give to chlorine because the chlorine is more electronegative than carbon. Alright. So and of course the carbon and Cl bond is polar. So it will break heterolytically, and the both of the electron are transferred to chlorine. Okay, to form what? To form C plus here. So kat sini dia akan break or fission. Okay, dia akan cleavage. Both of electron bagi pada Cl. Okay, and the carbon here become plus. So ini kita panggil dia carbocation. and the other product is Cl. Okay, Cl minus ion. So kat sini sepatutnya dia letak 2 dot lah, kalau tak letak pun tak apa. Okay, so because the atom here get both of the electrons. And then what is carbanion? It is very reactive species with a negative charge on the carbon atom. Okay, form heterolytic cleavage, form in heterolytic cleavage. So we only have two types of cleavage. Homolytic, okay, dia akan putus secara sekata. Okay, and then heterolytic cleavage, okay, dia unequally. Maksudnya ada satu atom akan dapat 2 elektron, another one tak dapat apa-apa. Right, but then for this case, okay, because of the difference in the electronegativity between carbon and lithium, which the carbon here, okay, is more electronegative compared to lithium. So carbon is partially negative, lithium partially positive. So carbon is more electronegative than lithium, and both of the electron will give to carbon. So it will break heterolytically, and both of the bonding electron give to the carbon. So it become carbanion, okay, which is the carbon here with the negative charge, and the lithium is positive charge cation. So here is carbanion. Alright, and then the third free radical, okay, the third one is free radical, the third intermediate is free radical. Okay, it's the same like before, okay, very reactive species with an unpaired electron. So it formed from the homolytic cleavage. So the radical is very reactive. Okay, for example, we have two atoms here, identical. That means they have same electronegativity. So it will break homolytically. Okay, one electron will give to both of the electrons. So each atom will get 1 electron symmetrically. Okay, so here the header here is half-headed arrow. Or you can write like this: chlorine, and then here, and here, right? So dia ada mesti ada bantuan UV and become free radical, okay, with 1 dot, with unpaired electron, right? So if you want to show the how the intermediate form, you must draw the arrow here. Okay, the tail is come from the bond and then give to the carbon. So the head here is shows to the carbon. Okay, yang mana dia, kat mana dia nak pergi. Okay, so ni adalah half-headed arrow, cuma dia tak berapa nampak. Alright, so kena ada UV, bantuan UV, and we will give here carbon, free radical of carbon. Okay, we have 2 free radical of carbon here. Okay, because of the carbon here is identical, same electronegativity. So the inductive effect of alkyl group. Okay, what is inductive effect? Okay, inductive effect of alkyl group on the stability of free radical carbon. Sekarang kita nak tengok stability of our intermediate. Stability of our intermediate. What is our intermediate? We have 3 types of intermediate: free radical, carbocation, and carbanion. Alright, so kita tengok dia punya stability. Okay, the carbocation, carbanion, and free radical can be classified as primary, secondary, and tertiary. Before that, kita nak tahu, kelaskan dahulu the intermediate. Okay, according to the number of alkyl group that are bonded to them. Okay, for example, we have a carbocation with hydrogen atom, 3 hydrogen atom. So ini dia tak ada kelas. Okay, it is methyl cation. And then we have 1 alkyl group. So this is alkyl group. Alkyl group or carbon. Just 1 carbon atom here. One carbon attached directly to the carbocation. Okay, known as primary carbocation. And then if we have 2 alkyl group, okay, we have 2 alkyl group attached to the carbocation, so it is secondary carbocation. And if we have 3 alkyl group attached to the carbocation, it is tertiary. Okay, what is alkyl group? Alkyl group is CH3, CH2, CH3. Okay, so bila dia attach to that carbon, maksudnya you just count the number of carbon that attach directly to the carbocation. Okay, so that's mean it is tertiary carbocation. Alright. So the inductive effect of alkyl group on the stability of free radical. Okay, so this one is for carbanion. Okay, kita kelaskan dulu carbanion. Okay, dia sama saja macam tadi nak kelaskan. We just count the number of alkyl group attached directly to the carbanion. Okay, so let's say we have this one, CH2, CH3. Okay, so kita tak kira ini sebagai dua, bukan. Okay, we just count how many carbon attached directly to the carbanion here. Okay, it is only one carbon. So another two carbon is hydrogen, hydrogen. Okay, so ini dikira sebagai one alkyl group. So if one alkyl group, that means it is primary carbon. Okay, we just count the bond that directly attached to the carbanion. And then we have two alkyl group, it is secondary carbanion. And then if we have three alkyl group attached to the carbanion, it is tertiary carbanion. Alright, so another one is for free radical. Okay, free radical bersama if there is no alkyl group attached to the free radical of carbon, it is methyl radical. And then if we have one only, okay, one alkyl group attached directly to the free radical of carbon, it is primary. Okay, primary free radical. And then if we have two alkyl group attached directly to the free radical of carbon, it is secondary. And if we have three alkyl group attached to the free radical of carbon, it is tertiary. Alright. So, alkyl group, okay, alkyl group is electron donating group. Remember, okay, so you have to memorize this. Okay, alkyl group is electron donating group. So we have if we have alkyl group attached to the intermediate, that means we have inductive effect, which the type is electron donating effect. Okay, so group inductive effect ni ada dua. Satu electron donating group, another one is electron withdrawing group. So alkyl group is categorized as electron donating group. So electron donating group is the pool of electron density through the sigma bonds caused by electronegativity of charge difference of atom. Alright, so alkyl group has the electron donating effect. That means dia akan increase, okay, dia akan increase the density of the electron pada carbon pada intermediate tersebut. Okay, so it will increase the stability of the carbocation and free radical. Okay, why? Because the carbocation and free radical, let's say the free radical of carbon, okay, they are lack of electron. They are lack of electron, kurang electron, lack of electron. So if we have the alkyl group that is electron donating group, okay, so it will give the more stability of the carbocation and free radical of carbon, okay, because of there are lack of electron. Okay, let's say kalau kita kurang duit, tak ada duit, okay, so we are unstable. But then if others donate to us money, that means we become stable. Alright, so we increase our stability because of the donation. Okay, sama juga macam ni. So alkyl group adalah electron adalah yang donate, dia bukan donate electron, but then dia akan increase the stability by increase the density of electron. Bukan donate electron, but then dia akan menyebabkan the carbocation and free radical yang lack of electron will stable because of the presence of alkyl group. Alright, So it increase the stability of the carbocation. The greater the number of alkyl group, so makin banyak alkyl group, which is the electron donating group on the carbon atom, so the greater its stability. Alright, so hanya untuk carbocation and free radical sahaja dia akan menyebabkan dia increase the stability. So more alkyl group, maksudnya the tertiary carbocation and tertiary free radical is the most stable because there are more alkyl group attached to them. But what about carbanion? Okay, carbanion is the carbon with negatively charged. So negative here shows that the carbon is has a reach of electron. Okay, so bila dia dah kaya dengan elektron, so dia tak perlukan pun electron donating group. Okay, so the presence of alkyl group, which is the electron donating group, okay, will make the carbanion is unstable or decrease the stability of carbanion. Alright, so ini contoh dia macam dia cakap tadi yang kita terangkan. Okay, so alkyl group, okay, alkyl group semua, alkyl group is electron donating group. Okay, it will increase the stability of the free radical. It will increase the stability. Why the free radical is unstable? Because dia kurang elektron, dia hanya satu sahaja. Okay, sorry yang ni tak ni semua meneruki pula. Okay, right. Okay, so hanya alkyl group. So the more alkyl group attached to the free radical of carbon, that means it is more stable. Alright. Increase stability. And then same with the carbocation. Okay, carbocation with a more alkyl group is the more stable. Okay, sebab carbocation is lack of electron, dia kurang elektron, so dia perlukan group untuk increase dia punya dia punya density of electron, so it will make it is more stable with the more presence of alkyl group. Okay, so carbocation and free radical is the same, okay, in terms of stability with the presence of alkyl group. But then for carbanion, okay, carbanion dia tak perlukan the alkyl group because it already has it already reach of electron. Okay, so the alkyl group, the presence of alkyl group will make the carbanion less stable. So the more stable is methyl carbanion, okay, and then followed by primary, secondary, and tertiary. And then, okay, try this with reference to the following reaction. State the type of reaction. Ini kamu belum belajar lagi. And then determine whether the alkene used in the reaction has geometrical isomers. Okay, so dia ada tak geometrical isomers? Yes, because the alkene group here, this is the restricted rotation about carbon-carbon double bond, and each carbon, okay, ini kita buat revision sikit lah pasal geometrical and this carbon have each of the carbon that attached to the carbon-carbon double bond, okay, each of carbon here has two different atoms or group of atom. That means dia adalah geometrical. Alright, so kita bila ada kita kena lukislah cis trans, and then show the bond cleavage that will occur in HCl and draw the species that result from the cleavage. State the name of the species from the cleavage. So dia nak show the bond cleavage. Okay, so you have to show by arrow. Okay, and draw the species that result. Dia nak species itu adalah produk dia daripada cleavage tadi. And then state the name of the species from the cleavage. Dia nak nama yang intermediate adalah. Intermediate adalah daripada cleavage. Okay, nanti dia ada kesinambungan. Nanti pasti kita sambung lagi. Okay, so if the question asks to show, you have to show by arrow. Okay, here the arrow is full-headed arrow because the hydrogen and the chlorine is difference in electronegativity. So chlorine is more electronegativity, so it will take both of the electron. Okay, hydrogen tak dapat apa-apa. So, it will become cation then anion. So the type of cleavage is heterolytic cleavage. Okay, because of the difference between the electronegativity, and then the species form here is cation and anion. And then show how the electrons in the CX bond in the compound below are distributed in the bond cleavage to form free radical. Okay, carbocation and carbanion. So kita kena nak buat free radical, carbocation and carbanion hasil daripada cleavage. Okay, hasil daripada cleavage between the carbon and X here. Alright, so if we want to produce the free radical, so this is the cleavage between the bond between C and X. Okay, between C and X. So this is the half-headed arrow, and then we will get C dot and X dot. And then if you want to produce carbocation, carbon here becomes C plus, so both of the electron will give to the X. Both of the electron will give to the X, and then we will get here C plus, which is carbocation, and X is X minus an ion. And then if you want to produce carbanion, okay, both of the electron between the bond C and X here will give to the carbon, and then it will become carbanion, and X is cation. Alright, so we have done 4.4 part 1. Okay, so our homework here today is Mastery Practices Chapter 4, number 10 until 13. Okay, macam biasa, submit in GC. Okay, so we will continue our lesson for part 2. Alright, thank you class.